We have a question here, question 5. The question says that the sketch below shows the graph of f and g. A and B are the x-intercepts of f, and the graph of f and g intersect at C and B. Now, question 5.1.12 says determine the coordinate of C. On the right, my question over here, it's question 5.1.1. Okay, this one. We need to determine the coordinate of C. When we look at C here is a y-intercept, okay? So meaning the x value is 0, and then the y value is okay. It may not be 0. Now we already know the value of x, which is 0. Now we need to find the value of y. Now we can notice that C lies on the graph of G, and also on the graph of G, yes, and also on the graph of F. I prefer to use G because it's much easier to solve with. So G of x is x minus 3. We can write it like y equal to x minus 3. Now x being 0, we just want to say okay, y equal to we sub in the value of x, which is 0 minus 3, and then we can find y, which is -3. So therefore, the point C is the point 0, -3. Now, the following question is says that calculate the length AB. Now, the length AB is actually, okay, let me first write the question here, 5.1.2. So we want the length AB. Okay. The length AB, A is here, and then B is there. There are these horizontal line. Now, to find the length, we first need to determine the point A and the point B, and then we can see they're both the x-intercepts of the graph of f. So x-intercept simply means we're going to make y equal to 0. Now f is given by y is equal to x squared minus 2x minus 3. So we are going to sub in the value of y. Y is 0, we sub 0 there. And then this makes x squared minus 2x minus 3 equal to 0. Now we can solve this by factorization. If I put x here and then close there, x there, and then close there also. And I'm going to consider the last step, which is -3. Over here, I'm going to write -3, and then let's list all the factors of 3. They are just 1 and 3. Now, if I need to get -2, this is possible if this is +1, I write -3. And of course, you see -1 times -3 makes -3. Then over here, I can just place in +1 and -3 equal to 0. Therefore, x plus 1 equal to 0, or x minus 3 equal to 0. This simply means that x is equal to -1, or x equal to +3. Then we have the x coordinates and the x coordinates of A and B. So over here, we know A being on the second quadrant, okay? So this must be -1 because it cannot be +3 being here behind 0. So it's -1, and then 3, B is 3 there. Now to find the length AB, we're just going to, we can use the distance formula. Yes, we can. But usually when we have horizontal line or vertical line, we just consider the coordinates. We just want to say 3 minus -1, okay? AB will be equal to 3 minus -1. And then this will make that AB equal to 4. Okay. And then that was question 1.1.2, and now we're going to do question 1.1 and 5.1.3. That says determine the coordinate of D. Where's D? Okay, we can see that D is over here. D is the what you call the turning point, okay, of F. So I'm gonna write it. Let's just move my board this way. I can just move all this over here because of space. And I'm gonna move this way, so I'm gonna write here 5.1.3. We are looking for the coordinates of D. And then we say that D is a turning point. Okay, there are different ways of solving the turning point. One way is to use the formula is X is equal to negative B over 2A. The turning point XTP, or XTP can also be the turning points can also be the difference between the intercepts. Okay, x1 plus the average of the intercepts x1 plus x2 over 2. In this case, I prefer to select any of these two, any of these. So let me just take okay. If I use this one, this will be xtp will be equal to minus 2. So that's going to be minus negative 2 over 2 times 1. So this would make 1. Okay, even if you do the average here, xtp, you can get the same answer. It's going to be negative 1 plus 3 over 2, and that makes xtp. The turning point is just 1 also. Now, is that all? Once you find the x coordinates, we also need to find, bless myself. You're welcome, sorry. Now that we find x, the turning point, we can also find the y coordinate of the turning point by substituting the value of x in the equation. So y being equal to x squared minus 2x minus 3, we sub in the value of y over there. So it's going to be x squared minus 2 times x minus 3. We sub in y, which is 1 there. And that will make y will be equal to 1 minus 2 minus 3. And this make y equal to negative 4. So therefore, D is 1, negative 4. That's the turning point. The point D. Okay. The next question says, let's see. The next question is question 5.1.4. That says calculate the average gradients of F between C and D. Okay, the average gradients of F between C and D. So it's actually, this is not a straight line. F is a curve, okay? So if we want to find the average gradients, it means actually the gradients of the points F, S, C, and D, okay, as if it was a straight line here. Okay, that's the average gradient. So now let's do it. Now right here, 5.1.4. We are looking for the average gradient of F at the point C and D. Now, the average gradient is given by what? I abbreviate like that. Average gradient would be equal to F of the formula is given by f of x2 minus f of x1 all over x2 minus x1. Okay, so in this situation, I'll take my points. Let's first see the graph again. I want to put the graph here. Okay, so we have like the points C and D there. Earlier we did find that C was equal to 0 and -3, and then we found that D is the points 1 and -4. Now, so if I need to work it out, I'm going to say the average gradient MAV would be f of x2. So f of x2, if this is like my x1, and then x2, and that's y1 is the same as f x1, okay, and that also f of x2, which is the value of y2. Now we're gonna do that's gonna be -4 minus -3, okay, all over excuse me, 1 minus 0. So this would be a -1 over 1, okay, and then this is just equal to M average will be equal to -1. So that's at average at the point C and D. Now, the following question is a question 5.1.5. This question, the question says that calculate the size of OCB. OCB is the angle, so OCB. So we're looking for this angle here. Okay, so before even I continue, I want to notice that this forms like a right angle triangle at this point by O there. Okay, if I consider this triangle here. Okay, it forms that right angle triangle. Then we can find this angle, and we know that this angle is equal to this angle here, or maybe we can find this angle, and we know that this angle will be equal to that angle because they are vertically opposite. Okay, and then doing this is 90 degrees over here, we can just say the angle OCB will be 180 minus 90, or just 90 minus this angle in blue. Okay, let's just do it over there. Move it like this. Basically, we have this angle as this triangle, right angle triangle, as I said earlier. Okay, so now this is right angle, and then OCB is this angle, and now we do know that this angle is equal to that angle because they're vertically opposite, and then we can use this information to find the angle OCB. Now let's do it. That's 5.1.5, the angle OCB. I can find we can find this angle here if we do the angle formed by that. How can we do that? Okay, we do know that the gradient is equal to tangent of the angle. Actually, yeah, it's something. Okay, that's the formula. Therefore, we can also work out theta will be equal to 10 minus 1 of the gradient. And now we can do that by the help of the calculator. First, let's find what was the graph. What was the gradient of the graph f? F was given by G. Actually, G of x was given by x minus 3. Now, the gradient here is just 1. So we can say the angle formed by G there is simply 10 minus 1 of 1 here. We can use our calculator to get it. I know 10 of 1 is 45, but let's just do it. 10, excuse me, of 1, like that. You press shift, okay? To get 10, press shift button here, the shift button, shift and then 10. Then you got 10 minus 1 of 1. This is equal to 45. Therefore, OCB equal to 45, equal to the angle OCB equal to 45 degrees. So we know this angle. We know that this one is equal to this angle is just 45 degrees. Is 45 degrees. So if this is 45 degrees, this other angle also is also 45 degrees. Okay, because vertically opposite. Now, this being 45 degrees, we can calculate, you know, we can immediately see that this angle, this other angle here is also 45 degrees. Because 45 plus 45 makes 90, plus 90 makes 180, some of the angle in the triangle fulfilled. Say, therefore, okay, over here, this was actually the value of the angle formed, the angle, this angle, as I said, we call it theta, and then this being 45, okay, sum of the angle, let me write the reason here, sum of the angle, some angle in the triangle. So we got also 45 degrees there. Now, question 5.1.6. So here, um, 5.1.6, the question says, determine the value of k for which f of x equal to k will have two unequal positive real roots. All right. Well, we can use the graph to do that, but it can be tricky. Let's first see how we're going to do it. How else we can do it? Okay, this is, let's say this is question 5.1.6. So we're looking for the value of k here, or values of k, for which f of x equal k will have positive real roots. What does it mean? Okay. We know that f of x was given by what? X squared. Let's see it again. X squared minus 2x minus 3. And now, we just said that this is equal to k. In other words, we can move k in. So this will become x squared minus 2x minus 3 minus k equal to 0. Now, roots, real roots are the values, you know that the values of the quadratic equations, that's our luck. You know, quadratic equation is given by x is equal to minus b plus minus square root of b squared minus 4ac all over 2a, okay? So now, it will have an equal root first, an equal root if the discriminant, the value b squared minus 4ac is is greater than 0, greater or equal to 0. Okay, that's where this can generate a real root. And then okay, before I do that, let's first do this. I prefer to write it this way. The first condition is that to have a positive, let me do this way. Okay, that's the quadratic formula. Okay, so if I want to have a positive result, because over here it generates two solutions. I will just want to show the proof. So that'll be like negative b plus square root of b squared minus 4ac, and negative b minus square root of b squared minus 4ac. Okay, now in our case, okay, let's just solve the problem like this. In our case, we have like x is equal to minus b, which is minus 2, plus minus square root of b squared minus 4. Okay, excuse me. I prefer to read this work this way, because like that's gonna make more sense. We have like this 3 minus k. Okay. Now it is important to note that the value of a here, the coefficients of x squared, a is equal to 1. Okay, b here is equal to negative 2, and c is equal to negative 3 minus k, which can be written as minus 3 plus k if I take the negative sign out. Now, in the quadratic formula that I wrote earlier, x equal to minus b plus minus square root of b squared minus 4ac all over 2a. This is the formula to find the roots of the quadratic equation. Now, in this situation, we know that we have two unequal roots if the discriminant, what is inside the roots here, is greater or equal to 0. Okay, but now the question says we want two unequal positive roots. Now this will be positive. This will be true if, let's first substitute the values here. Is this going to be x equal to minus 2, okay, plus minus square root of minus 2 squared, b squared, minus 4a, which is 1, and then c is negative 3 plus k, like that, over 2a, 2 times 1. Now, if we simplify this, this will be positive 2 plus minus square root of, that makes 4. And then notice that this negative sign here and the negative sign there, this will be positive. So that makes plus 4. 4 times 1 just 4. So there are 4 times 1 times 3 plus k. Okay? All over 2. Then this will become what? 2 plus minus square root of 4 plus 12 plus 4k all over 2. And then this will make 2 plus minus square root of 16 plus 4k over 2. All right, now to have a positive, for this to generate a positive root, real roots, this will happen only if the numerator, this part here, the result of this is if it is lesser than 2. Okay, why am I saying that? If this is more than 2, assuming that this was more than 2, okay, this is positive. This is positive 2. 2 plus another positive number will be still positive, but 2 minus a negative number. So if the number is more than 2, for let's say 3, for instance, or 2.1, 2 minus 2.1 will be negative, and then we want to have a real root here. So this must be lesser than the number that you see here. Okay. Therefore, I want to say, therefore, the square root of 16 plus 4k, okay, must be lesser than 2. Now we can set both sides to the power of 2, both sides, and then this will become 16 plus 4k lesser than 4. And if I move the 16 over, we have like 4k must be excuse me, lesser than 4 minus 16, and then that makes 4k will be lesser than 12. Okay, and then if we divide negative 12, I mean, if we divide both sides by 4, I want to divide here by 4, and then also by 4, and then this will be k must be lesser than negative 3. Okay, so now because k is lesser than negative 3, one side. Now on the other hand, what the contents of the square roots here, the 16 minus 4k, this part, okay, under the roots here, 16 plus 4k must also be this part here, 16 plus 4k must also be greater or equal to 0, because if it is lesser than equal to 0, the square root will not be real anymore. Okay, the roots will not be real anymore. So this must be positive. So if I move 16 over, we'll have like 4k will be greater or equal to negative 16. Okay, and then we divide both sides by 4, and this will make k greater or equal to negative 4. Therefore, we can say that the solution will be k must be lesser than negative 3 or more than negative 4. Then this can be written like negative 4 lesser than or equal to k, okay, and then k lesser than negative 3. Now, yes, so that's the interval. Thank you. So the value of k. And then the next question is question 5.1.7. 5.1.7, the question says that for which value of x will f prime of x times f seconds, so this prime you read it sometimes second of x will be greater than 0. Now let's see. I want to move makes 5.1.7. So we're looking for the value of x for which f prime of x times f seconds will be greater than 0, in other words, positive. Now f of x was given by x squared minus 2x minus 3. So now f prime of x will be then 2x minus 2, okay, and f second of x will be 2x. Now so excuse me, not 2x but just 2, because we differentiate over here, we derive this function, so it becomes 2x minus 2. The derivative of the constant is just 0. In other words, maybe someone would like to see all the steps. So it's like doing x squared minus 2x minus 3 derivative. So this is like x squared derivative minus 2x derivative minus 3 derivative. Now this will become because the derivative says that ax to the power of n derivative maybe like a times n times x to the power of n minus 1. So this will become then 2. The coefficient was just 1, so 2 times 1 x to the power of 2 minus 1 minus 2 times 1 x to the power of 0, and the derivative of the constant is just 0. Okay, a derivative is just 0. So minus 0, and then this will become 2x minus 2. Now f prime prime will be the derivative of is the first derivative of f prime. Is like we have like f prime derivative. Okay, so this is just 2x minus 2 derivative, and then this is just equal to 2. Now we will do in other words, to do the product here, it's this function, okay, times that function. So in other words, it's like 2 times 2x minus 2 greater than 0. Now we know that 2 is always positive, okay? So what we need to consider is 2x minus 2. So we're going to do 2x minus 2 greater than 0. This is possible if we move the 2 over. That will make 2x will be greater than 2. Okay, we're going to divide both sides by 2, by 2, by 2, and then this will be x will be greater than 1. So the value of x is that x must be greater than 1. Thank you.